Okay, fifth graders, today is Monday, October 21st, and we are continuing on. Last week we went up to lesson 9 in module 2, and today we're going to continue on with 10, okay? Today's learning goal is we are going to use what we know about place value to help us multiply decimals by whole numbers, okay? But first, let's review what we know by solving the problem of the day. Right, as you can see, last week we were talking about using area model and standard algorithm to multiply whole numbers. Today we're going to extend that knowledge to see how it relates to multiplying a decimal by a whole number, okay? But first, as I said, let's talk about the problem of the day. Okay, we're going to take what we learned last week and we're going to extend it, okay? We're going to use something very similar. We're going to use an area model and the standard algorithm to solve. Except this time, you'll notice we have a whole number, 43, times a decimal, 2.4. Go ahead and start by copying the problem down into your notebook. 43 times 2.4. A whole number times a decimal. Now, we're going to do the same thing we did before. We're going to draw an area model. So go ahead and draw a nice, big rectangle. Now, one thing I did differently was I wrote 24 tenths on the top, or 2 ones and 4 tenths on the top. Does it really matter? No. But remember, we'll see the partial products if we write the same number on top of our area model that we wrote on top of our standard algorithm. Okay? Don't worry about the standard algorithm yet. I just want us to look at the area model first. So I took the first factor, 43, and I broke it up into two parts, 40 and 3. Do you guys agree? Then I took the second factor, 2.4, and I broke it up into two parts, 2 ones and 4 tenths. If I just wrote a 2 and a 4, would that be correct? No. What form is this when I have a number and then the word ones, the place value? Unit. Yeah, this is the unit form. So we're going to use unit form today to help us. Okay? Okay, go ahead and set up your area model. With the area model, we know that we can find different partial products. In order to find the area of this partial product, or this part of the whole rectangle, we have to do 40 times 2 what? Okay, we're always going to write the units. If you don't write the units, I guarantee you will make mistakes. Unless it's ones. The only time I'm like, you don't really have to write the units is if it's ones, okay? If I have 40 copies of 2 ones, what do I have? 80 what? Ones. Good. Okay. Now what about this part over here? What's the length again? 40 times 4 tenths. Okay. So, we write the units so that we can do 40 times 4 is 60? Oh, 160. But, yes, write the units. And then let's convert that to standard form. 160 tenths is the same as? 16. Good. So you have one extra thing to do in your area model today is convert it from unit form to standard form. So draw it nice and big. Okay. Now, let's talk about down here. Okay. We have 3 times 2 ones, which is? 6 ones. Good. Okay, and then over here we have 3 times
4 tenths,
which is?
12 tenths.
Good. What do you think is the most important to write there? What part? The word tenths. Good. What is the standard form of 12 tenths? Well, I think to myself, I write 12, my number, and then I need the 2 to be in the tenths place. So where would the decimal point need to be in order for that rightmost digit, the 2, to be in the tenths place? Anurag? Good. So 12 tenths is the same as 1.2. Now, in order to find my entire product, I need to add up all those partial products, don't I? I know that I'm going to have a red slice and a blue slice. So let's find what the total of the red slice is first. 80 ones plus 16 ones, which is? 96. Good. Okay, and then the blue part, I have 6 ones and then 1.2, or 12 tenths, which is 7.2. Okay, watch carefully. In order to find the total product, I have to add up my partial products, 96 and 7.2. Am I ready to add?
No.
Taya, what fabulous fail did I make?
You didn't line it up.
Yeah. Do you guys see how my ones place is here on the 6 and the 1 place is over here on the 7? This is a very, very common fabulous fail, especially when you have 2 digits and 2 digits. Do you guys see that? Okay, so be careful. Make sure you match up your place value units. So I have 0 tenths, right, because I can think of this as 0 tenths, plus 2 tenths. So how many tenths do I have altogether?
2.
Great. I have 6 plus 7, which is?
13.
Okay. 9 plus 1.
10.
So my total product is 103.2. Looking at the standard algorithm, if my question was 43 times 2.4, how come it now says 24 times 43? What did I do there? Ikaksh?
You converted 2.4 into unit form.
Yeah.
Now it says 24.
I converted 2.4 and I renamed it using unit form. Instead of saying 2.4, I said 24 tenths. The reason why I did that is because when you multiply using the standard algorithm, you cannot have any decimal points. So by renaming it, do you guys see how I used a whole number now, 24, but then I used the units, tenths, to tell you actually there's a decimal point in there. Does that make sense? So now we can multiply. What's 24 times 3? Well, what's 3 times 4?
12.
Okay. And then what's 3 times 2?
6.
Plus 1.
7.
Okay. And then we're working in the tens, so let's put our placeholder 0. What's 4 times 4?
16.
Okay. What's 2 times 4?
8.
Plus 1. Okay. So if I add them all up, I have 72 and 960. So 2 plus 0 is 2. 7 plus 6 is 13. 9 plus 1 is 10. So I have 1,032. You know, it looks like it's the same digits, but it's not, because 103 is really different than 1,032. So what's going on there? We need to take into account our units. What's tenths times 1? Tenths. So it's 1,032 tenths, which in standard form is?
103.
Oh, so there we can see that actually our answers are the same when we use the area model and the standard algorithm. But let's talk about the partial products. My partial product was 96 and 7.2. I see things that look like 96, and I see things that look like 7.2, but they're not. Go ahead and talk to someone around you about what's going on there. Was I really multiplying 43 times 24 here? I was doing 43 times 24. So was it really 72? No. It was really 72. Oh. Was it really 960? No. It was really 960. Oh. So what's 72 tenths written in standard form? Oh, interesting, huh? What's 960 tenths written in standard form? Oh, did we have that partial product as well? So does it still work out like what we learned last week where the partial products are in the area model? It sure does.